Hello, this is the Math 159 Gould Chapter 1 Section 4 video about categorical data. So remember that categorical data, or a categorical variable, places your subject into a different category or group. So I'm going to quickly switch over to StatCrunch, the Pokemon dataset, so we can look at it. So let me change over to the Pokemon dataset. There we go. There we go. So there are several different categorical variables here. You can see type 1 is a categorical variable. Why? Because it places your Pokemon into different categories such as normal, bug, poison, electric, fairy, fire, and so on. In generation, because there was like first generation, second generation, and so on. Okay, so you might wonder well, actually let's look at this. I'm going to scroll all the way to the bottom of the data. And you can see that apparently there are 801 different Pokemon in this data set. So we have information about 801 different Pokemon. So if we're looking at their first type, type 1, there's a lot, you look at it and there's like, oh my god, here at the end, dragon, ghost, water, electric, fire, rock, steel, and so on. You're like, what sort of conclusions can I draw about this? There's so much information. There's 801 different Pokemon. I have no idea what's going on. So, when we are looking at categorical data and we want to analyze a single categorical variable, the first step is often something called a frequency table. So what's a frequency table? So a frequency table tells you the different values of the variable and their count in the data set. And another frequency is just another fancy word for count. Alright, so we're going to go back to the Pokemon data set. I'm going to explain, what do I mean by this? Okay, so first of all, our variable that we're dealing with here is type 1. The values are the different sort of type 1 responses that a Pokemon can have. So our first Pokemon here, which is Bulbasaur, its type 1 value is grass. Or let's go here, Charmander, its type 1 value is fire. Or Squirtle, its type 1 value is water. So water, fire, grass, those are all values. A frequency table will tell you, hey, there's a value a value called grass. How many different Pokemon have that value? There's a value called fire. How many different Pokemon have that value, and so on. So it will summarize all the information. It will tell you how many are of each type. That's why it's called a frequency table, because a frequency table counts something. This will count how many grass Pokemon there are, how many fire Pokemon there are. And it's pretty easy to do. When if you ever want to calculate something, you'll go to stat. In this case, we're making a frequency table, so you go to tables, and then there's frequency right there. This thing comes up. You choose the variable that you want a frequency table for. I want it for type 1. And you'll see here it says frequency and relative frequency. I'll talk about that in a moment. Just go to compute. Okay, so it opens this thing. And you can see frequency table results for type 1. And it says count 801. That's because there are 801 different Pokemon. So, remember that Bulbasaur was type grass. So if we go, it shows them all in alphabetical order. You can see here's type grass. You see how it says frequency? That means there are 78 different Pokemon who are type grass. There's also bug, 72 Pokemon are bug type. There's the dark type, which is, or dark value, there are 29 such Pokemon, and so on. So you can see there's a lot of different ones, and it defaults to showing all the values in alphabetical order. If you want to sort it by the largest group, you can click on frequency, so you can see the most rare type is flying. There are only 3 flying Pokemon. And the most common type of Pokemon is water. There are 114 of them. Okay, so frequency tells you the count. That's how many there are. Now you might be wondering, well, what's relative frequency? Well, relative frequency is just instead of the count, it gives you the percentage, but as a decimal. So there are 114 water Pokemon. It is the most common category, and it says relative frequency is 0.14. 0.14 is 14%. In other words, the most common type of Pokemon is water. There are 114 of them, and they comprise 14% of the total Pokemon. There are 3 flying Pokemon, and you can see for relative frequency it says 0.003. 0.003 is 0.3%. In other words, the rarest group is flying Pokemon, and they are 0.3% of all the Pokemon. Okay, so this is actually pretty useful. It tells you something. You can, right away from a frequency table, you can see which groups are most common, which are least common, how many of them there are in each group, what percentage of them there are for each of them, and so on. Okay, so let's go back to OneNote. All right, so frequency table gives you the count of the different values in the data set. Well, what if you want to analyze 2 variables, 2 categorical variables at a time? Categorical variables. Okay, so if you want to look at 2 categorical variables at a time, you make what's called a two-way table. Sort of makes sense? Two-way table. You're looking at 2 variables. Okay, so what is a two-way table? A two-way table counts the occurrences of pairs of values for each variable. So I'm going to make up an example here to show you what I mean. So let's say you have 2 variables, gender and, I don't know, favorite ice cream. So we're just going to call that ice cream. Okay, so let's say there are 3 men, and 3 males and 3 females. And of the 3 males, 2 of them have the favorite ice cream of vanilla. 1 of them has a favorite ice cream of chocolate. Of the females, they all have a favorite ice cream of chocolate. I'm just making stuff up here. So the values are male and female for gender. The values are vanilla and chocolate for ice cream. So if you look at this first row, this is an occurrence of a pair of values. The pair of values is male and vanilla. So in a two-way table, you specify something which is called the row variable and the column variable. So we're going to say that gender is the row variable, and we're going to call ice cream the column variable. So how many different values for gender are there? Male and female. So I'm going to have male and female in my two-way table. They comprise the rows for the row variable. So notice these values for the rows come from the values of the gender variable. Now, what are the values for favorite ice cream? We have vanilla and we have chocolate. It's called the row column variable because these form the columns of my two-way table. So here we're looking at how many males are there who like vanilla. That's what it means to count the number of occurrences of a pair of values. So you go and you look, and there's the first and the second row are the males who like vanilla, so you put 2. Okay. Over here, we want to know the males who like chocolate. Well, there's in the third row the single male who likes chocolate, 1. In here, we want the females who like vanilla. You can see that there are exactly 0 females who like vanilla. And over here, we want the females who like chocolate. There are 3 of them. Okay, so this two-way table shows you, okay, cool. If you want to look at just males, you could look at this and you'd see, hey, of all my males, 2 of them like vanilla and 1 of them like chocolate. Or you could look at just the females. Of all my females, 0 of them like vanilla and 3 of them like chocolate. Or you could look at the columns and so on. So let's go back and look at an example of this with Pokemon. So with Pokemon, we will quickly make a two-way table. We'll go to stat tables. You make a contingency table is what it's called in StatCrunch with data. So you have to choose your row variable and your column variable. So what we're going to do is we're going to look at their type. The row variable is going to be type 1, and the column variable is going to be whether they're legendary Pokemon. So let's compute. So you can see for the rows, we have all the different types of Pokemon, right? Bug, Dark, Dragon, Electric, Fairy, Fighting, Fire, and so on. Okay, and you can see that the columns are no and yes. So let's look at this first thing here. How many bug type Pokemon are there who are not legendary? Well, there were 69 non-legendary bug Pokemon. How many bug Pokemon were there that were legendary? 3 of them. So, and there were a total of 72 bug Pokemon. Of the 72 bug Pokemon, 69 of them are not legendary. You can also look over here, there's a total. This 731 is the total number of Pokemon that were not legendary. How many legendary Pokemon were there? 70 of them. How many Pokemon in total were there? 801. And then you can go through and you can look at all of these. Okay, so this is a two-way table. It gives you a frequency. There are different sorts of tables you can make. Just like the frequency table, you can make a relative frequency table. You can also calculate proportions of them. So I'm going to go at options and edit, and this allows you to change it. So you see how it says display? There's 2 different percentages you can calculate, row percent and column percent. So let's look at row percent first. Okay, so it changes the graph here. The table. You can still see that, let's look at the first row. There's the 69 bug Pokemon that were not legendary. There were the 3 bug Pokemon that were legendary of the 72 Pokemon. So let's say you want to look at, we chose row percent, my bad. So this 95% tells you that of all of the bug Pokemon, that's a row of bug Pokemon, 95% of them are not legendary. But let's go and look at flying Pokemon. Well, of the 3 flying Pokemon, 66% of them are not legendary. Or let's go over here to the dragon Pokemon. If you look at just the dragon Pokemon, that's a row. The 7 that are legendary are 25% of all the dragon Pokemon. So when you choose row percent, it allows you to analyze a row. You're saying like, hey, I just want to look at the dragon Pokemon. What percentage of them are or are not legendary? Let's say instead you want to do your analysis by column. So you can go from row percent to column percent. You can go compute. And now what this tells you is, let's look at this. We could look at this column of yes, all of the Pokemon that are legendary. So this 3 means the 3 bug Pokemon of all of the 70 legendary Pokemon, these 3 bug Pokemon are 4.29% of all of the legendary Pokemon. Okay, and this is the end of the Chapter 1, Section 4 video.